Okay, perfect. Right. So this morning I'm going to talk about reporting, monitoring, reporting, and verification of soil health. And to do that, I'm going to talk about what we can learn from the soil carbon experience, because we've thought about this a bit for soil carbon. It's difficult for soil carbon, and it's going to be even more difficult for soil health. But what I'm going to show today is the sort of things we need. We have most of the components that we need, and we just need to put them together. And that's something that's happening with the EU Soil Observatory, in AI for Soil Health, and in benchmarks and a few other projects. So I think we've got good reason to be optimistic that we can do this. So the first thing is that we have a bunch of soil health indicators, which are chemical, biological, and physical. To characterize soil health, or to get a soil health index, we have to have some aggregate measure. So this is just an example from the Soil Health Partnership, and these are the indicators that they recommend to measure to get an indicator of soil health, or to generate a soil health index. So it's quite complex. We need lots of different soil parameters, and we don't only need to know what the soil parameter is, we need to be able to determine a change in that parameter so we can track soil health through time. So what we've done in terms of soil carbon is we've tried to look at what can be done, what's available already, and how we can put this together into a decent monitoring, verification, and reporting framework. What we really need are low-cost estimates with low bias and a moderate uncertainty at project scale. We need fewer but high-quality direct measurements. So measurements are expensive to take, but we do need measurements, but we want those measurements to be of high quality and not too many, because otherwise it becomes prohibitively expensive. We want to reduce the uncertainty of local scale predictive models. We have models, a lot of models for many of these parameters for soil health. And Tom gave a couple of good examples there from Hawaii and from Latin America, which I think are great. And we have models in Europe, of course, for these two. And we need the capability to easily incorporate farm level activity data. So soil health is driven, it's changed by what on-farm practices the farmers or land managers use, or indeed in any other land use, urban, forestry. It's all determined by the management that's applied to the soil. So we need to be able to integrate that data, that activity management data, into the system. So what we did for soil carbon is we put together a review which just looked at what we've got. So basically, we've got long-term experiments at benchmark sites. We've got shorter term experiments which measure processes over different timescales. We've got great models of soil organic carbon or greenhouse gas, but you could substitute this for soil health models. We have spatial data to drive models, the sort of thing that OpenGeoHub does very well, in fact is world leading in, to put together those data cubes and those data layers that we need. We have activity data that's collected maybe at farm level that we want to integrate. We have remote sensing, which is becoming ever more powerful, and we can use that. And we also have spatial soil sampling, which are resampled at periods in time. So I'm just going to go through each one of these in turn and talk about how we can put these together into a soil health monitoring system. So most of the examples are for soil carbon, but you can imagine that we would use the same process for soil health. So this is another way to characterize it. So whilst we were putting together this paper for global change biology on an MRV system for soil carbon, Keith Paustian and colleagues, unbeknownst to me, I know Keith very well, he's a good friend, but he, with another bunch of co-authors, was putting together a very similar paper, and it's amazing how convergent our outcomes were. So it just shows that much of the thinking is going in the same direction. Two separate papers with no overlap in authorship, coming up with very similar ideas for how we develop an MRV system, albeit Keith had much nicer graphics than we did in our paper. So let's take the first one, long-term benchmark sites, long-term experiments of benchmark sites. So these maybe go on for multiple years. For soil carbon, we need to know how these things change over decades. So we can use these or chronosequences. But for soil carbon, we know that we have a bunch of long-term experimental networks across the world. So here's some examples. Up in panel A, we've got the land use change experiments. In panel B, we've got the tillage experiments evaluating the impacts on soil carbon stocks, and the ones that are looking at various agronomic practices and how that impacts soil carbon. We've got those long-term experiments on the bottom. So you see we have quite good coverage in Europe, North America, to some extent in Latin America and in Australasia, but poorer representation across the tropics and subtropics. And this is a recurring theme. If we're trying to do this globally, we have patches, areas of where we've got actually quite poor data coverage. Where we got those experiments, we can use them, so there are over 250 long-term experiments on soil carbon, soil organic matter turnover, soil nitrogen. So just some of the components that we would need for soil health, but they are there and they can be used, and we can use those to calibrate and to test our models. That's moving on to the second part. We also have shorter term experiments. So these some of these are at long-term sites, nested within them. They measure fluxes, they investigate processes, and we can use those to develop novel tools and to calibrate our models, especially the processes within the models. So some examples in terms of carbon include the FluxNet data site. So these are the FluxNet sites of 2012. There are many more now. And these use eddy covariance equipment, as that's shown on the left of the slide, which measure the fluxes of carbon dioxide, nitrous oxide, and methane, for example. And we can use those to calibrate our models for the greenhouse gas emissions and for other changes. And you can have similar sites, for example, measuring leaching, measuring other soil nitrogen and other parameters. So these short-term sites are very important, especially when we're testing and calibrating our models. And that brings me to the models. So they've developed using this short and long-term data. They can be evaluated against long-term data to see how they perform. We can use them to apply emission factors, or we can just use them directly to simulate changes. And we can link that up in a system, a cloud-based system where models are used to estimate change in soil health in real time. So some examples of the processes, these are soil carbon models again. So we have very simple models going to very complex ecosystem models. We can test it against flood data, natural abundance isotope data, pulse labeling data, long-term networks and soil respiration data, for example. We can then evaluate these models to see which ones perform best under the different circumstances. And when we know what is failing in the model, we can improve the process description and feed that back in to the beginning of the process to improve the models and go through the whole process again. And through data assimilation processes, we can automate this to some extent, and we can use AI to help us improve this process. An example one model, and this is the century model, just showing that we have pool-based models to simulate soil carbon change. In fact, there are over 250 models that have been developed since around about the end of the Second World War. So we have a great choice of models to use. And this is the NDC model. Next, we need the spatial data to drive the models, and this is where a lot of the focus of this meeting will come about. How do we collect that data, quality check it, and get it at fine spatial resolution, so that we can monitor soil health as it is at the moment, and so that we can predict and simulate and monitor change over time. So in terms of when we were looking at soil carbon, and we looked at in 2012, we had the Harmonized World Soil Database, we had WISE, we had the IGP database, and now, of course, we've got soil grids, and we've got many other products which are available at finer spatial resolution than we had over 10 years ago. So we're really in a great position going forward to have better and better data, and the data cube that Tom and colleagues are developing in AI for soil health will be a big step forward, as of course is the EU Soil Observatory, which we'll hear about in a moment from another keynote speaker. We need activity data, so it's only any use to know what's happening to soil health if you know what changes have been put in place to improve soil health, or what changes have caused a decline in soil health. So we need what's called the activity data. So that's the farm management data, and that's at farm or field scale. And this sometimes can come from on-farm reporting. We already know that farmers use either online or physical record books, which they have to record their practices, what crops are being grown, what applications they make to the fields, when they're what type of tillage they're doing, when they're doing it. So all this is collected routinely by farmers and farm managers, and if we can leverage that data, then we've got excellent fine spatial resolution data that's really tailored to the farm scale. If we can integrate that management data in a clever way into an MRV system, then we will have the management data that we need to drive the models and to feed into the MRV system to determine soil health change. In terms of remote sensing can be very important, very useful, because it provides it can be used to provide activity data. Remote sensing can be used to determine what tillage practices are being used, what stage the crop is at, if it's a crop. It can be used to drive models, and it can be used to provide other information directly. So this is an example from Keith Halcyon. This is an example of remote sensing of management activity data. So this is using optical and radar, multispectral and hyperspectral imaging to determine tillage and residue cover, crop type and crop cover presence, and flooding. And it can also be used for productivity surrogates. So we have things like NPP and leaf area index, from which NPP and GPP, gross primary production and net primary production estimates are used, which we can use to feed into the models, which drive the models that soil carbon turnover. So you can imagine similar things for the other components of soil health that we could use, various remote sensing products. And in fact, the lots of what we're going to hear about over the next few days are giving examples of how these remote sensing products are being used to improve our predictive capabilities. And lastly, there's the spatial soil sampling data set, which are undertaken by many national governments, national soil surveys, where there are repeat sampling. So sampling maybe 25 years ago, and we go back today or next year, and we see how those things have changed over time. And a great example was the soil survey in England and Wales, and this paper published by Pat Bellamy and colleagues way back in 2005, which was looking at resampling data to try and determine if there'd been any change in soil organic matter or soil carbon over those 25 years. So these repeat samples over long time scales can give us excellent verification data, which we can use to test our system. So I'm trying to get us back on track in terms of timing. So one of the biggest challenges for developing a system for soil health monitoring is developing this MRV system for soil health, because we don't only want to know the status of soil health, but we want to know the change in status critically. We want to know how it's changed from time period 1 to time period 2, and that's one of the biggest challenges. Indicators of soil health differ in their maturity in terms of our ability to measure, model and track them. For some of them, like soil carbon, I've given that example mostly today, that's actually very mature in terms of our ability to predict them. As I said, there are many models that attempt to do this. But others, for example, some of the biological measures are much more difficult to predict and to model. So we're at the different stages of the development. So I feel that we're going to need to put in additional research and development for some of these parameters. For some of them, it's just a matter of pulling things together. And for some of them, it's developing better modeling frameworks to enable to simulate and predict what's going to happen in terms of those parameters. And the examples that I've shown today is, I think, perhaps the easiest indicator, but even that is difficult. We don't have an MRV system globally or even nationally that is reliable yet. But as I've shown, we have all the components. We have all these different long-term experiments, short-term experiments, the farm management data. These are all collected at different scales, different platforms. So what we need to do is we need to pull these together into an MRV system that can be used by the land managers and farmers in the field, and can also be used by policymakers to determine what policies to put in place to improve soil health. So as I said, all components of this framework exist for most indicators, but there's uneven coverage globally. So if we're thinking beyond Europe, we need much more data in the tropics and subtropics and underrepresented areas of the globe. And there are various components, but they're not yet integrated. So that's partly what we're trying to do in AO for soil health, and probably in benchmarks too, and other European projects. But it's something that we're moving towards. And I think within 5 years, 10 years, Tom wants soil health now. I think that's great. That's very useful. But I think we can start doing soil health now, and we can improve our MRV systems as we move forward. And lastly, I'd say there are great opportunities for robotics, AI, machine learning, data assimilation, and advanced modeling. Some of those are being developed within AI for soil health and other European projects. But I think we're only just starting to realise the power and an opportunity that these relatively new systems have for improving MRV systems. So I'm looking forward to that developing over the next 2 or 3 years. And I think we're going to come on very, very quickly, in the same way as ChatGPT went from 0 to hero within the space of a few months. I think many of these new technologies will be coming on stream very, very quickly. And I'm looking forward to the improvements that makes in our ability to monitor, report, and verify soil health. So thank you for your attention. I'll leave it there and take any questions.